Look, what we're covering today is a documented, honest stress test. No marketing fluff, absolutely no sanitized vendor demos. I'm a 30-year enterprise IT veteran and a former Air Force crew chief. My entire career has been built on discipline, problem-solving under pressure, and learning to trust systems only after I've verified every single piece of them myself. In this briefing, we're looking at exactly what happens when you take that hard-earned discipline and you hand complete control of a production-grade home lab over to an AI for a full week. We're going to look at the data, evaluate the outcomes, and figure out what this actually means for IT professionals working on the ground.
Here's our flight plan for this after-action report. We'll start with the briefing, move into the proving ground, cover the execution, tally up the honest scorecard, face the hard truth, and finally, I'll give you your marching orders. Let's get into it. Part 1. The briefing. Let's set the stakes for this experiment.
So the central question driving this entire briefing is this: what actually happens when an experienced architect steps back and lets an AI, specifically Anthropic's Claude in this case, take the wheel? To find out, I treated the AI exactly like a junior engineer on probation. I delegated real tasks to it, I documented what worked, logged what completely failed, and flagged exactly where I would never trust this AI to operate unsupervised. We are looking for unvarnished, practitioner-focused results here, nothing less.
Moving to Part 2, the proving ground. Enter Project Helix.
Listen, the specific environment for this experiment, Project Helix, is not some beginner's toy sandbox. It's a deliberately structured containerized ETL that's extract, transform, and load pipeline environment. It's running on Docker Desktop, WSL2, MySQL, Python, DuckDB, and Metabase. It pulls real public health data directly from the CDC Chronic Disease Indicators dataset using a live API. It follows a strict layered architecture, raw, staging, and analytical with a proper star schema. This is the exact same discipline I bring to massive enterprise modernization programs, just compressed down onto a local machine. If the AI was going to succeed, it had to survive here, under these strict constraints.
Part 3. The execution. Time to hand out assignments.
Looking at the high-level execution data, honestly, the results were a decidedly mixed bag. The AI handled tasks like SQL generation and backup automation surprisingly well. But when it came down to nuanced coding and overarching architecture, well, we hit the limits of current large language models pretty fast. Let's break down the specifics.
For our first task, I told the AI to write a Python extraction script from scratch based on my schema definitions. Now, it produced a working script on the very first attempt, which is commendable. But it completely whiffed on critical context. It failed to handle API pagination for large datasets, and its staging logic just ignored how null values needed to be treated in my specific dimension columns. A junior developer would have shipped those bugs straight to production. On the flip side, Task 2 was brilliant. I had a connection refused error between Metabase and MySQL. The AI systematically diagnosed the issue and correctly identified that I was using localhost instead of the container service name, which is a classic virtualization gotcha. It solved a complex Docker networking issue without ever physically touching my machine.
Tasks 3 and 4, this is where the AI was squarely in its wheelhouse. When I asked for a Metabase dashboard query, it generated clean, highly readable SQL. It used proper window functions, flawless group by logic, and it executed perfectly on the very first run. For Task 4, I needed a PowerShell backup script. Not only did it successfully automate zipping up my key lab directories with timestamps and error handling, it actually over-delivered. Completely unprompted, the AI added an email notification feature using send mail message to alert me upon failure. It was such a solid, useful addition that I kept it in the final code.
But Task 5 is where we hit a wall. I asked the AI to evaluate the Project Helix architecture and recommend a path for deeper pipeline automation, specifically without introducing any cloud dependencies. Its recommendations, like leveraging lightweight local orchestration tools such as Prefactor Airflow, were directionally sound, but it lacked the localized judgment necessary to make implementation decisions tied to my specific hardware and constraints. Look, the AI can point you in the right direction for sure, but you still have to think the problem through yourself.
Part 4. The honest scorecard. Let's tally it up.
All right, here's the honest scorecard. The AI did exceptionally well with structured code generation across multiple languages. Systematic troubleshooting, documentation, reducing boilerplate setup, it knocks these out of the park consistently and fast. However, we ran into severe danger zones when it came to context-specific edge cases, resource modeling, and nuanced judgment calls. And most importantly, hear me on this. AI-generated code cannot be trusted without a manual security review, period. It simply doesn't know what matters to your specific architecture.
Which brings us to part 5, the hard truth. Let's unpack the junior engineer fallacy.
Think of AI as a highly capable, yet completely inexperienced junior engineer. It can execute clearly defined tasks, quickly and at high quality. But it fundamentally lacks judgment regarding risk, operational context, and organizational constraints. Your job, as the practitioner, is to be the senior engineer in the room. You have to define the task precisely, review the output critically, and you have to catch the gaps.
This dynamic creates what we call the experience gap. The uncomfortable truth here is that AI makes experienced people dramatically more productive, but it does absolutely nothing to close the experience gap for beginners. If a beginner relies on AI without the foundational skills to validate the output, they are eventually going to ship broken code and they will have absolutely no idea why it failed. Building real, hands-on lab skills where you break things and fix them yourself, that's not optional in the age of AI. It is more critical than ever before.
Furthermore, we have to draw a hard line between a personal home lab and a true enterprise context. In regulated environments, strict data handling and security requirements are completely non-negotiable. Using AI tooling in those spaces requires rigorous evaluation of data residency boundaries, mandatory security certifications, and strict authorization to operate validation. What you can do freely in a personal lab environment like Project Helix is not automatically permissible when you're dealing with regulated enterprise systems. You absolutely must know your environment's boundaries before integrating AI into your workflow.
All right, final section, the marching orders. Let's talk actionable steps.
If you're an IT professional, a career switcher, or maybe you're transitioning from the military to tech, here are your marching orders. First, stop overthinking it and just build a local lab environment. Second, procure a real dataset. Do not use sanitized perfect tutorials. Third, break things, fix them, and document every single thing you learn. Finally, use AI strictly as a tool to accelerate your workflow, never as a replacement for your own foundational understanding. At the end of the day, AI rewards those who already understand the systems.
As for this experiment, the next phase of Project Helix is going to double down on the local lab environment. We're pushing the architecture even further, with AI-assisted infrastructure as code, deeper orchestration, and advanced pipeline work. And we are doing all of it 100% locally with absolutely zero dependency on cloud platforms or enterprise cloud spend. The home lab is the proving ground, and that's entirely intentional. Real skills are built locally.
I'll leave you with this final thought. Paralysis is the biggest mistake you can make right now. You don't need another certification to start building. Will you step up and lead in the age of AI by mastering the fundamentals? Or will you sit on the sidelines and let the tools leave you behind? The choice is yours. Get to work.